academic, November 28th. Let's get those notes back out. We'll move on to 3.3, talk about logs. All right, evaluate the following. Okay. Think of the best way to explain logarithms, okay? So, logarithms. How do I explain what a logarithm is? So a logarithm is the opposite. A logarithm is an exponent, okay? So when you look at a logarithm like this, are you doing okay, Emily? You're finished? Okay, cool. Let me email Mr. Springer back real quick. Cool. Okay, so think of the vocab here. Yeah. Okay, I'm not going to use the vocab. So I'll make this, call this the blue number. I'll call this the red number. Okay, so the way a when you see a log like this, this is equal, this logarithm here is equal to the number. Let's think about this. The number we raise the blue by to get the red number. Okay, so 5 to the what? So this is going to be, this is like saying 5 to the what equals 5. 5 to the what equals 5? 1, yeah, so this first one is equal to 1. Okay. For B, anyone know what B would be then? 4 to the what? So 4 to the what equals 16? 2. Yes, the second one would be 2. Okay. Bless you. You're welcome. Okay. ELN. Has anyone ever seen the LN symbol before? LN just means log base E. Okay? So e to the what equals e to the 10? Let's look at that. You can solve that. E to the what equals e to the 10? What's the question mark there?
1.
E to the 10. So e to the what? Look at this. Yeah, it's 10. Yep. Okay. What that's saying is to get e to be equal to e to the 10, we take e and raise it to the 10th. Okay, so kind of a lot of word salad coming from me. But another way of saying that is when these two numbers match, when the base of your logarithm, this is called the base, this number that's right here in the corner. When it matches what's inside, they just cancel out and your number is just equal to what's right here. Whatever's right there, okay? Here we go. Here's one. Anyone have any idea how to do this one? Yeah.
Can I see actually A again real quick?
A. Yeah. What were you going to say, Kate?
Is it like 1/3?
Yeah, good job. So you can rewrite the cube root of e as e to the 1/3. Okay? And then ln, again, remember ln is just log base e. Okay? So what this is saying is e to the what gets us e to the 1/3. And then 1/3, yeah. So that's equal to 1/3. Okay. All right. Okay, so the big takeaway, right, is I'm going to write this in the left, right. When you have like log base a of a, that's raised to the x. Okay, these cancel out, and you're just left with whatever's in that exponent there. X. Okay. So like log base like 4 to the 4 cubed would be equal to 3, because these cancel out, and you're just left with that exponent there. Does that make any sense? So when you see similarly, these are going to cancel out too. Okay? So when you have like a number a raised to the log base a of x, that just equals x. These cancel out. Okay. So 6 to the log 6 of 10 would be equal to what? 10. These are going to cancel out. Okay. Okay. Conceptually, what this means, log base 6 of 10, what that is, this is the number we raise 6 by to get 10. Okay. So if we raise 6 to that number, we're just going to get 10. Okay. A lot of word. Okay. I think the simpler way for you guys to understand it is like they just cancel out. Okay. So this one, what's f going to be equal to? 2, yeah. Right? There's an 8 and then a log base 8. Those are going to cancel, and we're just going to be left with this guy right there, okay? Feeling okay about that? Cool. So, 4 log base 2 of 2. So this is 4. This is equal to 4 times log base 2 of 2. Okay? I'm going to squiggly, all right, I'll highlight. That part I just highlighted here, what's that equal to? So what happens? What happens when there's a log base 2 raised to the 2? What did we say happens? They cancel, right? So what are we left with? 1, right? There's technically an exponent of 1 here. There's technically an exponent of 1. So those two are going to cancel and just leave me with 1. So this equals 4 times 1, which equals 4. All right. Let's remember what ln means for this next one. What's this next one equal to? E to the ln 6. It's called natural log. E to the natural log of 6. Okay, so we said something like log base 6 of 6. Sorry. We said something like 6 to the log base 6 will cancel itself out, right? Well, ln is what? That's log base what? E, right? So e to the log base e is going to cancel as well. So e to the ln is going to cancel. So this gives us what? 6. Make any sense?
So if it's ever e ln two numbers, always cancels?
Yeah. Yeah. And you're just left with the guy that was inside the logarithm. Okay. Here's a fun one. I. For letter I, what's this one going to be equal to? So, right, what do we say? How do we evaluate these? 8 to the what equals 1? 0, right? So this evaluating this is the same as asking ourselves 8 to the what equals 1, and that's 0. Okay, does that make any sense? So whenever you see a 1 inside of a logarithm, it's going to be 0. Okay? Any number raised to the 0 equals 1. Okay. What about J here? J. Anyone have any idea for J? In honor of JJ. Let's have JJ take a swing at this. So, yes, you can cancel. What's that square root? Here's one thing I want to say, guys. Whenever you see a little check mark symbol, I want you to rewrite that with its corresponding exponent. So square root of 7 is the same as 7 raised to the 1. 7 to the 1/2. Okay? So this is the same thing as log base 7 of 7 to the 1/2. Okay, then what do we say? You were on the right track. Then what happens now? Cancels. Cancel, so it's equal to 1/2. We just keep this 1/2 here. Make any sense? Good job. Good job. Cool. Okay. All right, so quick little review.
For like 1 second.
What's that?
Can you go back down to the
Yeah. Whenever we have a number raised to a log with that same base, it cancels. Whenever we have a number, actually, yeah, that's like the same thing I just said. All right, here, whenever we have a logarithm, a number inside a logarithm with the same base, they cancel. Sorry, I'll just use my laser pointer. Okay, so that's what we got so far. And then ln, another thing is ln just equals log base e. It's one thing we got to note, okay? Moving on to part K. Can I move on to part K? When I see log of 100, what's the base of this logarithm? When it doesn't have a base, right? The base is what? This little number right down here in the corner? Good guess, 10. Whenever it doesn't have a base, just write in 10, because that's what that means. Okay, that's just like how mathematicians. Okay, so what's this equal to? 2, right? Because evaluating this logarithm is the same as asking ourselves, 10 to the what equals 100, and that's 2. Okay. All right. What's that?
Isn't there like a trick where if you count how many zeros there are and stuff? You'll, like,
Yeah, if you have like a 1 with trailing zeros, however many zeros there are is going to be. Yeah, that's true. Okay. Log base 3 of 1/9. How do I evaluate this guy? So we're saying we have to ask ourselves, 3 to the what equals 1/9? What do I raise 3 by to get 1/9? -2. Okay. Right. So here's another little trick. Okay. Whenever you see a fraction inside of a logarithm, you're going to get a negative answer. Okay. And that's because. Okay. Let me qualify that. Whenever you have a whole number base and then a fraction right here, you're going to get a negative answer. And that's because to raise a whole number to a number and then get a fraction out of it, you've got to do something to move this number to the bottom of the fraction, which means you need a negative exponent. Okay, it's probably just confusing what I just said. Okay? If you just like to think 3 to the -2 equals 1/9, you can also do that. Okay, so 3 to the -2 equals 1 over 3 squared, which equals 1/9. Okay, that's algebra 2 review. You should remember that. Okay. All right. How we feeling? Feeling okay? Here's one you guys should know how to do. Let's have JJ take another swing at it. So I want you guys to do what? What did I say I want you to do whenever you see like the little check mark symbol? I want you to rewrite it as what? Okay, let's let JJ answer. So how do I rewrite then? 6 rooted to the 3.
Is it you turn to a fraction?
Yeah.
So 1/3.
6 to the 1/3. Good job. And then what's my answer? You got it. So what do we say? What happens? What happens with these over here? What happens? Cancel. So I'm left with what?
So 1/3.
Yeah.
Oh.
Keep whatever. Yep. There we go. Good job. Good job. Okay. All right. Another good trick. I'd say another good trick. Let's try rewriting our fractions with negative exponents. Okay. So ln of 1 over e cubed is the same thing as ln of what? Yeah, let's get rid of that fraction. It's going to be the same thing as ln e to the -3. Okay? And ln is the same as what, Silas? Not quite. Let's look at what I wrote on the board. Yeah, log base, same thing as log base e. So log base e of e to the -3, what happens here then? It's going to cancel, and we're left with what? -3. There you go. There you go. Okay. Okay. 1 over 16 is the same as 4 to the what? 4 to the what equals 1 over 16? -2. That's the same thing as log base 4 to the -2. Those cancel, we're left with -2 there. Okay? You feel okay about this? Are we just copying down what I'm saying, or are we actually understanding? Yeah, Maddie.
Why would you not do, hard? Why would it not be,
Where right now? Cube root of 6 is not 2. That's 8. Cube root of 8.
Oh, shit.
Yeah, okay, for letter P, what do I do whenever I see a log with no number, with no base? What do I write in? 10. I don't know what happens here. Yeah, they're going to cancel. That 10, that log base 10 are going to cancel. We're just going to be left with 7. Right. Same thing. Okay, Jade's out. All right, what do I do when I see a log with no base? What do I write in, Jade? Yeah, and then 10 to the, so 10 to the what? Yeah, equals 1,000. It's 10 to the 3. So this is just this next one, R, is not too bad. Elise, you have an idea? This is 2 times log base 3 of 9. What does that log evaluate to? Yeah, so this is the same as 3 to the what equals 9? 2, yeah. So it would be 2 times 2, which equals 4. Did you follow that? All right. Here we go, Maddie. 3, this equals 3 times log base 2 of 8. What's log base 2 of 8? Yeah, good job. Yeah, so this, right, this log here, log base 2 of 8, that's the same as saying 2 to the what equals 8. And that what is 3. 2 cubed equals 8, okay? So we have 3 times 3, which equals 9. Final answer is 9. Okay. And then let's do Michael. That last one. What happens? That last one?
Yeah, you can just cancel out the E
And
with
the
that.
L, yeah, good job. Good job. Awesome job. Good work. Good work. Okay, so yeah, logs. You know, they're a little weird at first, a little outlandish, but once you catch on, it's pretty simple.
What do you use this for?
Logs, like in the real world, or oh my gosh. Let me think of the best. That's actually, yeah. So real world application of log. Let me think of like exponentials are everywhere. And then log is the inverse of an exponential. So you're going to see it in a lot of different places. One is different like things grow logarithmically. So like the Richter scale is what's called, for earthquakes, it's what's called a logarithmic scale. So you use logarithms for that. Yeah, there's all sorts of stuff.
I'm not gonna.
Who's going to be a geologist? Hey, my uncle's a geologist. I know, like, just having studied physics, just know that like everything you learn in this class is like used in everything. So, like your phone to connect to GPS, right? It's got to connect with satellites in space, but those satellites are under, because they're farther from the Earth than we are, they are under less gravity. So you have to correct for general relativistic effects in order to program how to connect your smartphone to GPS. Okay, and there's a lot of math involved. Yeah, and you have to do what's called curved geometry to do general relativity, because space-time, when there's gravity, is curved. It is no longer a straight line. Okay, so that's a little short answer. Okay, let's solve these. Let's solve these. Okay. So this is just like in Algebra 1, right? Solve means you get x by itself. You get x by itself, okay? So I spy with my little eye a log with no base. What do I do when there's no base? What do I write in? 10, yeah. Okay. So we have a base 10 log of x equals 3. We got to get the x. We got to break the x out of the log. Okay. How do I do that? Anyone remember? So let's think about this. Okay. If only I could like cancel something. If only I could like cancel the log with something. Yeah, so you put a 10 on both sides. You 10 to the log, base 10 of x equals 10 to the 3. 10 to the 3. Okay? So 10 raised to the left side equals 10 raised to the right side, right? Because the two are equal. And then this is going to cancel. We're going to get x equals 10 cubed, which is 1,000. Okay? All right? Okay. For B, right? That's like almost the exact same thing, right? What do I write in here when there's no base? A 10. And how do I get rid of that log? How do I break the x out of that log? I do what? Yeah, I do 10 to the left. 10 raised to the left equals 10 raised to the right. Okay? And I do that because I want these two to cancel. Yep. Okay, and then I get x equals 10 to the negative 1, which is 1 over 10. Okay. Feel okay? C, log. What do I do when there's no base? 10, yeah. Good job. Okay, and how do I break the x out? 10 to the left equals 10 to the right. Okay, those cancel. We get x equals 10 to the negative 2, which is the same as 1 over 10 squared, which is 1 over 100. Okay. All right. D. Can I move on to letter D or no? D. Okay, so ln is the same as what? Log base e, right? So this is log base e of x equals 4. Okay, so I got to get the x out of this log. If only there's something I could write to cancel with the log. E. So I'm going to do e to the left equals e to the right. Okay, so these cancel, and I get x equals e to the 4th. We'll just leave it as e to the 4th.
So e would be x equals e to the 6.
E to the 4th.
So e, but so letter e, would that just be the same thing with just 6 and 6?
Sorry. Yeah. Yeah, the same thing, right? All right, we rewrite the ln as log base e if you want to. Over time, you'll get better. You'll just see it. Okay. Okay, and then, oh man, so then we, e raised to the left side equals e raised to the right side because the two are equal. This cancels. We get x equals e to the 6th. E to the 6th. All right, 3 times log x, okay? Let's do, I want you guys to get the log part by itself before we start fiddling with the log, okay? So what do I have to do here to get the log by itself? I get rid of this 3, right? So let's divide by 3 on both sides. Get log x equals 1, and then you guys know how to do this, right? There's no number here. What do I write? 10, okay? Raise both sides. Okay, we get x equals 10 to the 1, which is just 10. Okay. This next one, right? What do I have to do first? Divide by negative 2. Okay. And then e, raise both sides. E to the left equals e to the right. Okay, those cancel, so I get x equals e to the negative 2. 3.3 homework for next time. We'll finish these last 3 examples next class, but I think we know enough. Let's try the 3.3 homework for next time. Good work today, guys. This is a good vibe, much better vibe. I was vibing.